Have you ever, looked up at the night sky and wondered, like, if our universe is all there is?
Yeah, it's a question that's captivated thinkers and scientists for
For
centuries.
sure. And the idea of other universes, like parallel universes existing alongside our own, I feel like that used to be, pure science fiction, right?
Right, relegated to the realms of imagination and speculation.
But now it's like, it's not just science fiction anymore, is it?
No, not at all.
This is a concept that's being taken seriously at the cutting edge of, like, modern physics.
It really is. And what was once purely in the realm of thought experiments is now a subject of intense scientific inquiry.
And that's exactly what we're diving into today in this deep dive.
Oh, this is going to be fascinating.
We're going to be exploring the mind-boggling world of parallel universes.
A world, or rather, worlds beyond our comprehension.
And to do this, we've delved into a variety of sources, everything from, foundational discussions on the nature of reality
Right, down to the bedrock of what we think we know.
to some really, really in-depth scientific articles that are exploring the potential evidence for these other universes.
Evidence that is, of course, incredibly elusive, but nonetheless a focal point of contemporary research.
And what's so cool is that this idea of parallel universes draws from these like really diverse areas of physics. Like you have quantum mechanics,
Right.
cosmology, string theory. They all kind of converge on this possibility.
It is fascinating how these different branches of physics, which approach the universe from different perspectives, all seem to hint at the possibility of realms beyond our own.
Yeah, exactly. It's like they're all pointing in the same direction.
A direction that leads us beyond the familiar, beyond the known.
Now, for you, our listener,
Because we always want to keep you in mind.
we know that you want to understand these big, complex ideas, but you don't necessarily have all day.
We want to make it digestible and not overwhelming.
Exactly. So we're going to do our best to break these concepts down.
We're going to take these intricate theories, complex ideas, and present them in a way that's both accurate and engaging.
So you can grasp those core ideas and really get a sense of like the implications, the philosophical implications.
Because those implications are profound, really shaking our understanding of reality.
All right, so let's start with the basics, okay?
Yeah.
What exactly do we even mean when we say parallel universes?
Well, at its most fundamental level, a parallel universe is essentially an alternative reality that exists alongside our own.
Okay, so alternative reality, but like what does that even mean?
Well, that's where things get really interesting, because alternatives could encompass a vast spectrum of possibilities.
Okay.
These parallel universes could be radically different from our own.
So not just like a mirror image of our universe.
No, not necessarily.
Remember, things are slightly different.
It could be far more profound than that.
Right.
We're talking about universes that might operate under completely different physical laws.
Okay, so like gravity could work differently.
Exactly. The fundamental constants of nature, the numbers that govern how the universe behaves at its core, those could be entirely different.
And we're talking about constants like the speed of light, the strength of gravity.
All of those, and potentially even the number of dimensions in space and time, could be different.
Wait, hold on, dimensions.
Yes.
So we're not just talking about a universe where I, wore a different shirt today.
No.
We're talking about universes that could be fundamentally, structurally unlike our own.
Precisely. And that's where the concept of parallel universes becomes truly mind-boggling.
So where does this idea even come from? Like, what are the scientific roots of this whole multiverse concept?
Well, there are several key areas of modern physics that provide the foundation for these ideas.
Okay.
One of the most important is quantum mechanics.
Oh yeah, the realm of the very, very small.
Exactly. And within quantum mechanics, you might have heard of this concept called quantum superposition.
Refresh our memory.
Sure. Essentially, at the quantum level, before we observe a particle, it can exist in multiple states simultaneously,
Oh,
like a coin spinning in the air.
it's not heads or tails until it lands.
Precisely. It's in this blurry state of both possibilities at once.
Okay, so how does that relate to parallel universes?
Well, there's an interpretation of quantum mechanics called the many worlds interpretation
Okay.
that takes this idea of superposition and applies it to the entire universe.
Whoa, okay, I'm listening.
So instead of the universe collapsing into a single outcome when a quantum measurement is made,
Right.
the many worlds interpretation suggests that the universe actually splits.
It splits.
Yeah, creating a separate universe for each possible outcome.
So like every time a single particle, like an electron, has to decide between two paths.
The universe splits, one where it takes one path and another where it takes the other.
And that's happening constantly.
Constantly, at every moment, on an unimaginable scale.
So the reality we experience is just one tiny branch on this like massive, ever-expanding tree of
A
possibilities.
truly mind-boggling concept, isn't it?
It really is, and we're just getting started.
Oh yes, there's so much more to explore.
So we have quantum mechanics, but what other areas of physics point to parallel universes?
Well, another major pillar is cosmology, the study of the universe as a whole,
Okay.
and specifically, the theory of cosmic inflation.
Inflation, so like when the universe was a baby and it had this like crazy growth spurt.
Exactly. In the first fraction of a second after the Big Bang, the universe expanded exponentially.
So fast.
And this rapid expansion could have led to different regions of space inflating independently,
Okay.
creating these bubble universes.
Bubble universes.
Yeah, think of it like a foam of universes, each bubble representing a separate self-contained cosmos.
Wow.
And these bubbles, these universes, could have started with different initial conditions,
Oh,
which means they could have developed with different physical laws, different constants.
so our universe, with its particular set of laws, is just one of these bubbles.
One bubble among a potentially infinite multitude,
It's like we're not even a drop in the ocean anymore.
more like a bubble in a cosmic foam bath.
Okay, so quantum mechanics, cosmology, what else?
Well, let's venture into the realm of string theory.
Oh, yeah, this is where things get really theoretical, right?
It is, but also incredibly intriguing.
So, for those who haven't heard of it, what is string theory in a nutshell?
In essence, string theory is a framework that tries to unify all the fundamental forces of nature, gravity, electromagnetism, the strong and weak nuclear forces.
Okay, a theory of everything.
Precisely. And it does so by proposing that the fundamental building blocks of the universe are not point-like particles.
But tiny vibrating strings.
Exactly. Imagine incredibly tiny one-dimensional strings that vibrate at different frequencies.
Okay, and these vibrations, what do they do?
Well, those different vibrations give rise to the different particles and forces we observe in the universe.
So, like how different vibrations on a guitar string create different musical notes.
Exactly like that, but instead of musical notes, you get electrons, quarks, photons, gravity.
So, string theory, how does that lead to parallel universes?
Well, string theory also suggests that the universe might have more dimensions than the four we experience.
Wait, more dimensions, like beyond length, width, height, and time.
Yes, extraspatial dimensions.
Okay, so where are these extra dimensions? Why can't we see them?
The idea is that these extra dimensions are curled up incredibly tightly at a subatomic scale.
Okay, so they're like hidden from our perception.
Precisely. And within these curled up dimensions, the strings can vibrate in different ways.
And those different vibrations lead to different universes.
That's one of the possibilities, that these different vibration patterns in the extra dimensions could give rise to different universes with different physical laws.
Wow, that's like a whole other level of mind-blowing.
String theory is full of such mind-bending concepts.
Okay, so we've got quantum mechanics, cosmology, string theory. Any other big ones contributing to this multiverse idea?
Well, there's one more cosmological theory we should touch upon, and that's the oscillating universe theory.
Okay, tell me more.
So instead of a single Big Bang,
Which is what most cosmologists believe started our universe.
right, the oscillating universe theory suggests a cyclical model. The universe expands for billions of years, then eventually, under the pull of gravity, it contracts.
So like a big crunch.
Exactly. And then this crunch could potentially lead to another Big Bang, starting the cycle anew.
So our universe, the one we know and love, wouldn't be the first, and it wouldn't be the last.
It would be just one cycle in an eternal cosmic dance of expansion and contraction.
Wow, that's a pretty epic idea.
It is, isn't it?
Yeah.
The universe as this eternal breathing entity,
So we have all these different areas of physics pointing towards this possibility of parallel universes.
each offering its own unique perspective and theoretical framework.
And our sources mention that scientists have actually categorized these potential parallel universes into different levels or types.
Based on how they might be connected to our own universe and the underlying theories that support them.
Can we break those down?
Absolutely. Let's delve into these levels.
All right, level one, what do we got?
So level 1 universes are perhaps the most straightforward.
Okay.
They stem from the idea that space is infinite. And if space is infinite and the laws of physics are uniform,
Meaning they're the same everywhere,
then statistically, everything that can happen will happen.
including an exact copy of our universe.
Exactly. Somewhere out there in the vastness of space, there should be a region that's identical to our observable universe.
And not just our universe, but like me sitting here recording this.
In theory, yes, an exact duplicate of you having this very same conversation.
That's both bizarre and kind of comforting.
It's a peculiar thought, isn't it?
It is. Okay, so what about level 2 universes?
Level 2 universes get a little more exotic.
Okay.
These are the bubble universes we talked about earlier.
Right, the ones from cosmic inflation.
Exactly. And the idea here is that different bubble universes could have different physical laws, different constants.
So not just a different arrangement of matter, but like fundamentally different rules governing those universes.
Precisely. Imagine a universe where gravity is weaker.
Or where the speed of light is slower.
It's mind-boggling to consider.
It really is. Okay, level 3 hit me.
Right. Level 3 universes take us back to the realm of quantum mechanics,
Okay.
and specifically the many worlds interpretation.
Right, where every quantum choice creates a split in the universe.
Exactly. So every time there's a quantum measurement, every time a particle has to choose a path,
The universe branches, creating a new universe for each possible outcome.
so in one universe you might have had cereal for breakfast, and in another you had toast.
And both universes are equally real.
Precisely. They're just separate branches on this vast, ever-expanding multiverse.
Okay, so we're up to level 4. What's the final frontier?
Level 4 universes are perhaps the most abstract and speculative.
Lay it on me.
This is the realm of the mathematical multiverse.
Mathematical multiverse, okay?
The idea here is that every mathematically consistent structure, every possible set of mathematical equations could correspond to a physically real universe.
So if it can be described by math, it might exist.
That's the essence of it, although it pushes the boundaries of what we could even conceive of as reality.
It really does. Okay, so we have all these theories, all these different levels of potential parallel universes.
But the big question, of course, is whether any of this is actually real.
Right. Can we ever prove that these other universes exist?
That's the challenge, and that's where the search for evidence comes in.
So what are scientists looking for? What kind of evidence could point to these parallel universes?
Well, direct observation is likely impossible.
Yeah, if these universes are truly separate.
Then we can't just hop in a spaceship and go visit them.
Right, so we need to look for indirect evidence.
Exactly. Subtle clues embedded within our own universe.
So what kind of clues?
One promising avenue is to look at the cosmic microwave background radiation.
Oh yeah, the CMB, the afterglow of the Big Bang.
Precisely. And if our universe collided with another bubble universe in the distant past?
Colliding universes, that's wild.
It is. But those collisions could have left imprints on the CMB,
Imprints like what?
like unusual temperature fluctuations or patterns that don't fit with standard cosmological models.
So like a weird cold spot on the CMB could be a sign of a cosmic fender bender.
It's a possibility, and scientists are actively searching for those kinds of anomalies.
Okay, so the CMB. What else?
Another potential source of evidence comes from gravitational waves.
Gravitational waves, those ripples in space-time.
Exactly. And some theories suggest that interactions with parallel universes could produce unique signatures in these waves.
Signatures we could detect with our gravitational wave observatories.
Potentially, as our detectors become more sensitive.
Okay, and on top of that, scientists are constantly refining their mathematical models.
Right, developing sophisticated computer simulations to test these theories.
So like a virtual multiverse laboratory.
In a sense, yes. Trying to tease out the observable consequences of these theories.
It's like a cosmic detective story.
It really is, using the tools of science to piece together the clues of a reality that might be far grander than we ever imagined.
Okay, so even if we can't directly observe these parallel universes, just the idea that they might exist has some pretty huge implications, right?
The implications are profound.
Like what?
Well, for one, it suggests that our universe, the one we know and love, might not be unique.
Right, just one of countless others.
And if that's the case, then it really changes our perspective on our place in the cosmos.
We're not the center of everything anymore.
Not even close. And it could also explain some of the mysteries about our own universe.
Mysteries like what?
Well, for example, the fine-tuning problem.
Okay, explain that one.
So, the physical constants of our universe seem incredibly finely tuned for life to exist.
Like if gravity was just a tiny bit stronger, or the weak nuclear force was slightly different, stars wouldn't form, planets wouldn't form, life as we know it wouldn't be possible.
Exactly. And this has led some to propose that our universe was somehow designed for life.
But if there are countless parallel universes,
With different constants, different laws.
then it becomes statistically more likely that at least one of them would have the right conditions for life.
Precisely. So our universe wouldn't be special, just one of the lucky ones in the cosmic lottery.
And the multiverse idea also has implications for some even deeper questions like free will, destiny.
Oh, absolutely. If every quantum choice creates a new universe,
Then does that mean there's a universe out there where I made all the right decisions?
perhaps,
Where I actually stuck to my New Year's resolutions?
maybe, who knows, but it certainly makes you think about the nature of choice and consequence.
It does. And then there's the question of extraterrestrial life.
Right? If there are countless other universes,
Then the odds of life existing somewhere else go way up.
it's almost inconceivable that we would be alone in a multiverse.
So we might not be alone, just separated by these cosmic barriers.
Barriers that we may never be able to cross.
Okay, so this idea of parallel universes, it's not just limited to scientific papers, right?
Oh no, it's captured the imagination of popular culture as well.
I mean, it's everywhere in books, movies, TV shows.
His Dark Materials, Interstellar, Everything Everywhere All at Once. The list goes on and on.
Why do you think this concept resonates so strongly with people?
Well, I think it speaks to our fundamental curiosity about the unknown.
Our desire to explore the limits of reality.
And it allows us to grapple with these big questions about our place in the universe in a way that's both entertaining and thought-provoking.
Now, I'm sure not everyone in the scientific community buys into this whole multiverse idea.
Right. There are definitely challenges and controversies.
Like what?
Well, the biggest challenge is the lack of direct evidence.
We can't see these other universes. We can't touch them.
And some argue that if we can't directly observe them, then they're not really within the realm of science.
Right, it becomes more philosophical.
But even if we can't directly observe them, there might still be ways to find indirect evidence.
Right, like the CMB anomalies, the gravitational wave signatures.
Exactly. And as our technology advances, who knows what other clues we may uncover.
So it's still an open question and a very active area of research.
It's a frontier of science, pushing the boundaries of what we know and what we thought was possible.
And what about the future? What are some of the most exciting developments on the horizon in this field?
Well, there are several promising avenues.
Okay, tell me more.
For one, there's ongoing research into dark energy.
Dark energy, that mysterious force that's accelerating the expansion of the universe.
Right. And some scientists believe that dark energy might behave differently in other universes.
So different forms of dark energy could lead to different kinds of universes.
Exactly. And this could have huge implications for the potential for life in those universes.
Okay, so dark energy research is a big one. What else?
Well, as our gravitational wave detectors become even more sensitive.
We might be able to pick up those subtle hints of interactions with other universes.
It's a long shot, but it's a possibility.
And then there's the rise of quantum computing.
Oh yeah, quantum computers could revolutionize our ability to simulate these complex theories.
So we could create like virtual multiverses to test these ideas.
Exactly. It's a really exciting time to be exploring these concepts.
So for our listeners who've stuck with us on this incredible journey through the multiverse,
We appreciate your curiosity and your willingness to delve into these complex ideas.
let's recap, shall we? We started by defining what we even mean by parallel universes.
Right, those alternative realities that could exist alongside our own.
We explored the different scientific theories that support this idea.
From the quantum realm to the vastness of the cosmos.
We looked at different types of parallel universes.
The simple level 1 universes to the mind-boggling mathematical multiverse.
And we discussed the ongoing search for evidence.
The subtle clues that might reveal the existence of these hidden realms.
And we've only just scratched the surface. But hopefully you, our listener, now have a better understanding of this complex and fascinating topic.
And hopefully it sparked your imagination, made you think about the universe in a whole new way.
So as we wrap up this deep dive,
We'll leave you with this final thought.
if countless versions of reality exist, what does that mean for our understanding of ourselves, our choices, our place in the grand scheme of things?
Does it diminish our significance or does it enhance it?
We invite you to ponder these questions, to keep exploring, to never stop wondering about the true nature of reality.
Because the universe, as we're discovering, is full of surprises.
Guys, see you in another podcast. Don't forget to subscribe to our channel